as I said, we won't be able to finish this before lunch, so we can still further do some exercises after lunch. But the automation, we've came across the automation word, you could say, on various places. I've already mentioned it when creating a Visio drawing. You can add a nice button on a Visio, go to backup, and a whole procedure is being executed. When you have a scheduled task being executed on specific times in the evening, changing things in your network. Also in our correlation, we were able to trigger automation. So automation can be triggered from all kinds of places. So here we will take a look on how to do and how to create such an automation script. We'll take a look at a quick introduction, then going into the UI, organizing scripts and folders. That's a little bit like correlation rules. It's all about designing the scripts with variables and actions. We'll take a look at all the different actions, and then we'll create an example as well. Actually, it's quite simple. It's not that difficult. It's just a series of actions we will add. That's basically what an automation script is. Just a number of things I want to execute. Let's take a look at that. So, as I said, from various places we can execute the automation script, but we need to go to our automation module, which can be found just on top of the correlation module in our apps section of the surveyor. Let's take a look at that. Again, similar as the correlation application, we have a folder structure with all the automation scripts where we can nicely organize that. Whenever you select an automation script, you see on the right-hand side your effective automation scripts. And you can already see an automation script. It has a little bit of a general section, some dummies and parameters. I'll come back to that. And here are just the actions, and you can actually read that. It's very easy. You can just say, oh, this one is doing a get of a parameter, the audio output level, put it in a destination variable, and also the LMB1 supply and 2 supply does some if statements. So you can just very easily read that. Also, to create that, that's going to be quite easy. Well, we actually have two types of automation scripts. This is what I call the dummy-proof version. It's easy, it's with drop-downs, you just click on it, you do gets and sets and ifs, and you can easily read it. There is also the C# version. That's what I will also show you how to do that in a second stage. Okay, so the tree structure, as with the correlation, you right-click on there, you can add a new folder, you can duplicate, you can add a script. Also, the buttons, the default things, will create a folder, will add a script in there, etc. So that's possible. Note in the right-click, you also have import-export. Meaning if you created an automation script on your staging platform, you can export it from there, and then on your production environment, you can import it again. So you can easily export and import an automation script as well. Okay, then when we created our folder and we added our automation thing, let me just immediately already do that maybe. Let's close whatever I have here, or let's go to automation. So the automation gives us some folders here. We can add a new folder again. New folder. Let me call it again 000 training. Let's make it capital maybe. Okay, now it's going to the top. That's going to be more convenient. Let me just add a new script in there by clicking add script. Give it the naming convention training underscore my first name and do a first save. So you should also see that folder now, I believe, or maybe reopen the application so that you can already create one if you want to take a look on what is available in there. So the first thing I will take a look at is the general and the details that we have in there, and then we'll go through the dummies, parameters, memory files, and add some actions in there. The first thing, as always, name, description, we know that by now. In the details, there are a couple of special checkboxes there. The first one supports back and forward buttons in interactive mode. Remember, we've seen a couple of examples of interactive automation scripts, and some of the interactive automation scripts, they gave us a nice UI where we can still specify some details and then click on the next. Well, there you can specify if there's a back button as well. Only applicable, of course, for interactive automation scripts. The next one, do not fail when elements are not active or in timeout. Actually, if I execute an automation script on some main and backup devices or whatever, the first thing the automation engine does is check if those devices are active and not in timeout so that it can communicate with the device. That's good if I'm copying it from the main to the backup, some settings. They need to be active, otherwise, yeah, it won't be able to execute. But sometimes if you have just like a dozen of devices and you will check yourself in the automation script which one you take, you don't want this check to happen. So therefore you can actually disable that check. Write comments to log file, that's more for the debugging purposes. We'll see we can add an action or an action line in there, which are just comments to make sure that it's readable, your automation scripts. If your automation script is taking a long time to execute, you might want to enable that checkbox, and then all the comments in between your automation script will be generated as logging items. So you can maybe see, oh, this first section goes quite fast, and there it apparently takes a long time before the device locks onto the correct frequency there, for instance, onto the signal. The last item is for C# specific if it needs to return a null value or an exception when the get parameter is not initialized. That's a little bit of a special corner case, you could say. Now, we can immediately start in there with designing a script and adding some actions in there. Adding the actions, you can all see that on the right-hand side. That drop down is showing you a long list of possible items. So you can see we can do a whole bunch of things. What I will do is I will browse through those items and explain them one by one what the things are you can do. So I'll browse through that so that you know a little bit what it's about. As soon as you add actions, they are being added in here. And in here we added a set on a parameter. And then you can add some more actions. And on the right hand side, you can still change the order. So you can reorganize the order of your steps. You can duplicate and you can delete a line on the right hand side. So that's how you can organize and add steps in there and reshuffle your steps very easily with the automation. Now, before I add my first actions, we noticed in our view on our automation script, there is a top section there, dummies, parameters, memory files. What is a dummy? What is a parameter? And what is a memory file? Well, if we create an automation script, we won't create an automation script hard-coded on one specific device. We will make it as generic as possible, meaning that we are not working with the device BERT IRD main or BERT IRD backup or your device because I don't want to create 20 different automation scripts. No, I want to create one automation script for a Philips device. Which one? Well, I'll see that whenever I execute it, because if I execute an automation script, I can execute it on my main, on my backup, on your device, So I'm not working with actual devices or actual elements. We are working with so-called dummies, a placeholder. So that's what a dummy is. We already have one dummy here, the dummy Phillips, the dummy for a Phillips element. What is that? It's just giving a name and a protocol, and that's something where we will be able to work with during our automation scripts. So that's a dummy. We also have parameters and memory files. What are those? Parameters is typically taking information from the outside world because I want to reconfigure my automation, my audio output level to which value? I don't know. I'll ask the user. So that's an incoming parameter. That's basically what it is. And the memory file is just like things to store information while executing your automation scripts. So that's something we will look at here. A memory file is basically an array of pieces of information, data, and you can actually store memory files on the server. Because maybe I have a list of channels and I want to list all the channels in a memory file so that the user can easily pick a channel. Or I have a list of frequencies. I maintain that list of frequencies inside a memory file, and during the execution, I can pick up those frequencies and use them to execute that and set it on a specific device. So a memory file is an array, a list of data, and you can have it volatile or persistent. Typically, mainly it's going to be persistent, at least the ones that we can manage on the server then as well. What is volatile? Volatile is just during the execution of your script, it exists, and at the end of the script, it's removed, it's deleted. So it's more during the script that you can store certain things and maybe give it to a subscript. Persistent is something that is stored on the hard drive of the DataMiner server. So meaning even if you shut down the DataMiner system and you reboot the operating system, those things will still remain there. And that's why we also have a memory file viewer, because you can actually create those beforehand as well, with a list of services, with a list of frequencies, etc. So a memory file, a storage, an array of data that I can use during the execution of my system. You can manage those memory files, and let me show it in the UI immediately, because next to my automation scripts on top we have memory files, and we can actually take a look on the hard drive of the DataMiner system. It's system-wide actually, on what is already available there. Apparently they created a list of cities and a list of SNGs. And let me see, a list of matrix inputs, those are channels, list of matrix outputs. So you can actually add any kind of list of information in there so that this can be used during your execution of your automation scripts. At the bottom, you can add a new memory file. You can delete memory files as well. You can just click in there if you want to change or add a new city in there. You can click on the add. It adds a 13th row value 13, and the city is, of course, the capital of all cities, Izeham. They forgot about that one. How is that possible? So that's where you can manage those files, and during our execution steps, our actions that we will add in an automation script, we'll see that you can leverage those memory files. All right, memory files, a data container, a list of items I can use during the execution of my scripts. So just to recap and make sure you have the difference between a memory file and a parameter as well. So we have three things we can use throughout our automation engine. We have those dummies, those placeholders for the elements. So I'm not working with real devices, but I'm working with placeholders. So if I need to copy settings from a main Philips device to a backup Philips device, I need two dummies, the source dummy and the destination dummy. And when I execute it, I need to choose on which devices I execute it. The second thing, parameters, is something where you say, like, I want to query, I want to ask something to the operator when he is executing it. You need to execute it to a new or apply a new audio output level. I'm not going to hard code it to 6, but I want to ask the operator to which one it is that he wants to set it to, 6 or 9 or 12. And I also have that memory file. That's a data container of data like frequencies or things that I can use throughout the execution of my automation script. One thing I forgot to mention there on the parameters, there is also a values file. So I'm asking here to the user a new audio output level. There is also a values file there. What is that? If you don't specify a values file, like in this case, you can just type in everything. You can type in 6 or 12 or 100 or even your name you can put in there. So there's no validation on it. Especially if you have channel names, for instance. Yeah, is it now BBC World with a space or not a space? Or so therefore you can actually rely on the values file, which is referring to a memory file with all the possible values. That's why we had in our memory files a list of cities. So then we create a parameter, give me a source city and a destination city. And the source city, you need to choose one of the cities. And the cities is a memory file with a list of the cities. And when you execute it, you will say source city, and then you have a drop down, and you have all the possible cities, including Israel. And for destination, you do the same thing. So that's how you avoid that people need to type in something and that they can make mistakes with that possible values, that values file there. Okay, let's now take a look at our first actions there. So the memory files, we took a look at that. The first action is set. Very simple. I want to set the audio output level. So if I add an action in there, what I will have is I will have a set, and typically I go for something like a parameter. So you can do some other sets as well, but let's assume parameter. Parameter, the Philips device, the audio output level to the value 3 or 6 or 9. Of course, I can not work with my Philips device, but I need to use that dummy. We'll do that in our exercise as well. So that's going to be the source Philips device, the audio output level, and the value could be hard-coded or could be something that you asked to the user. We'll play with that in an exercise as well. So typically here we set a parameter. You can also change a memory file or change a variable. So we have variables that we can change with a set as well. But set is changing a parameter typically on a device. Of course, I can get it as well because I get the frequency from the main device and I set it on the backup device. So first I get the parameter. So I go for getting a parameter from the source, Philips device, the audio output level. I store it in a variable, and then going one slide back, I actually do the set on my destination Philips device, the audio output level to the value whatever I stored, the variable that I used in the previous step. So you can get the frequency, store it, and then do a set on another device. So get and set is of course going to be an important one. That's what we will also use in our exercise. You can also do an if statement. If you add the action if, you will get a whole building block. So this is the building block I have. The building block I see is the if with a condition I can add in there. So I have on top in the blue the if. For instance, if my LNB1 supply is on, I do something, or if it's off, I do something else. So if my LNB1 supply is on, then I do something, else I do something else. So I can add some actions in the then, I can add some actions in the else. So those are the two items I can, or the two things that I can add in there. Note if I'm adding a condition there, if my LMB1 supply is on, that's perfectly fine without the wait for a positive result. There is a small checkbox, wait for a positive result. But let's assume that the step right in front of this if statement is setting the frequency of an IRD. I know it takes a little bit of time before the signal gets locked. So if I put in my if statements, the condition, if my signal is locked, then I continue with my automation script. So I make sure that it accepted the new frequency and locked onto that signal. But I know it typically takes a few seconds. So what will I do? I will add the condition in there if my signal is locked, but I wait for a positive result for, let's say, 10 seconds. I allow the device to give it a little bit of time. So it will check if it's locked. No, it's not locked yet. So it will again check and check and check and check, and it will do that for 10 seconds. And if after a few seconds it's suddenly locked, it will immediately continue. If after 10 seconds it's still not locked, it will just stop. And do the else statement if you define something in the else, of course. Okay. If statement, you add a condition with an optional wait, and then you can go into the then part or else part and add further actions in there. What else do we have as actions? A simple sleep. So I change the frequency and I allow the device to wait a little bit and adapt to the new situation. So a simple sleep can be added in there. A script can also call a subscript. If you have reusable automation scripts, sometimes instead of making one big giant automation script with everything in there, sometimes you want to break it up a little bit and have smaller subscripts that do stuff. And then typically you have like a main script that does a couple of checks and executes a subscript here and executes a subscript there and uses those subscripts. So within a main script, you could say you can call other subscripts. Don't worry about those options. Those are executing options. I'll come back to that later on. Sending an email is possible. So you can send out an email, the subject, the message, and include the report again. So we know that interface by now. Sending a text message. If you have a mobile gateway attached to your system, you can send a simple text message to the persons as well. An information event, that's a little bit more for audit trailing. So you can also generate an information event. That could also be used a little bit as debugging, you could say. Instead of going to the log file, check the information events. For a report, you can also upload it to an FTP and a shared folder. So those are the details. You can go through it, IP address, port, the path, the username, password, if you need to connect. Yeah, what is the difference between an MHT and a PDF? In a PDF, I assume you know that, but an MHT, that's actually an HTML file. So it's a web page. If you double click on it, it opens up in a web browser. But it's a package. Why is it not HTML then? Well, it's actually a package that also includes not only the HTML, but all the images that belongs to the web page. So it's a way of getting a complete web page with everything it refers to into one file. So the PDF is opening in like Acrobat. The MHT is opening in a web browser. So that's also possible to execute that. And here comes an interesting one, that interactive or user interaction. Here we can add all of the sudden, while we did several steps in our automation script, we did some gets and some sets, and maybe somewhere in an if statement, we detect, we're missing information. So we'll need to ask the user something or maybe show them something. And here we can build, and you can see that on the left-hand side with a preview, you can build a UI on the right-hand side with a little bit of text, with a variable, so you can also show dynamic data. You can add some text box, a drop down, a button, so you can add several items, and you can see whenever you're adding more and more items underneath here, it builds up the UI on the left-hand side. That's how you can make a wizard page, you can say, where you can just add those items on top of each other and show something to the user or ask something to the user. Depending on what he chose, on which button he clicked, if you add a button there, do you want to continue yes or no, or do you want to do the switch yes, it will do if this or if that, do so different things depending on that input. And it will just do a little bit more on the server, maybe a little bit later on it says like, oh, I need to ask something again, come to the user. Of course, this can only run if you are executing it on the server, if you are executing this by the user. I have a quick example on that in our interactive view, interactive automation view. And let me just make sure that this device is getting started here. So I have a Philips device, and the audio output level, I can set it too high or too low. Just wait a second before it starts up. And then we have a button, Device Diagnostics, that is actually going to help you to diagnose the problem that is happening with this device. Okay, it's starting up, coming green, slowly. Just gonna have to wait until my audio output level gets populated. We're gonna have to take a look at that. Set it to low. So it's going to set it to 0 dBm, okay. And now we can run the device diagnostics. It is an interactive automation script, and it says the audio level diagnosis has been executed and no issues have been detected. Okay, that was good. Let's set it too high. Let's try again. So if I set it too high, oh, there it is. A first verification revealed that the audio output level on this device is higher than normal. The current value is 21 dBm. Check manually if the audio level on a reference setup box is acceptable or not. And then you can say it sounds normal or, yeah, it sounds too loud. And then it says like, yeah, maybe it's recommended to put it on 3 dBm. Do you want to set it to 3 dBm? Oh, yeah, let's try it out. Let's put it on 3. You can see in the backgrounds, it takes a little bit of time before the device accepts the new value. And there it is, 3. And it's now you can check again, is it normal or no, it's still too loud. And then it will say like, yeah, maybe you should just send an email to the engineering team, and you can say like help, and it will send submit and send out an email to engineering. So that's a whole interactive automation script that is being executed step by step. It helps you, it does something, it does a setting, it guides the people or the operator through a whole procedure. So that's what you can do with here and there putting some interactive automation scripts in there, some user interfacing. So between each step you can do actions. Now I executed that automation script by clicking on a button. So it knows that I'm executing the automation script. If I would do it with a scheduler or a correlation rule, it would not have a user to talk to. So this kind of automation script that wants to communicate with the user needs to be executed by user. It cannot just be executing on a scheduled basis, because if you run it tonight at 8 o'clock, with the scheduler, this automation script would say like, yeah, and who do I need to talk to? I cannot just run by myself on the server. So an automation script can be without user interaction running this night, overnight on the server. If you would execute this one that I just showed you on the server at 1 o'clock in the night, it would say like, there's nobody to talk to. Well, you can also find an interactive client. So you can say, well, actually, I want to do something. The correlation is picking up a problem and it wants to do certain things, but it gets to a point where it needs a little bit of a human being to talk to and to get a confirmation from a human being. So it can find somebody to talk to. And here we can add an action. So you can just in your automation script say, find interactive client, show a message, something like help, I need somebody to talk to. And you can put also a timeout on there, because if this thing would execute in the middle of the night, we are not going to be here. So then it would time out after 100 seconds because nobody reacted. And it would effectively just go to some kind of emergency procedure and take decisions by its own anyhow. Let me show you how that works. We have an example on that as well. If we go to our USA service, we will see that we have over here a little bit like we've seen before already, like a main and a backup in Las Vegas we have there. So we have a redundancy there. We have Las Vegas to receive the level, but also LA is standing by. So we have a site redundancy with also a main and a backup in LA. So we have quite a lot of redundancy. And on the upper right-hand side, you can see there's a poker tournament ongoing there. What will happen if I generate an alarm on the first Las Vegas main device there? Well, DataMiner will detect that problem and it will automatically react on that by switching to a backup. Okay. Fully automatic. What will happen if I generate an alarm on the backup in Las Vegas? So the whole Las Vegas site is going down. Then it will need to do a site switchover. And actually we find that a little bit, intrusive, and we want to make sure that an operator gives approval, you could say, to be able to do that switch. So what will happen? The correlation engine will pick up on that, execute an interactive automation script that the first thing it will do, it will find an interactive client here in the class. So if I generate the alarm, what will happen? Everybody has now this pop-up. Don't click on it. You can attach or ignore. If you ignore, you say like, okay, I didn't see that. If you click attach, you can see the signal is down, by the way. If you attach, I take ownership of the automation script and the pop-up disappears on all of your clients because I took ownership of the interactive automation script. And now I'm taking ownership and I said like, yeah, a problem was detected. Okay. And I can go there and I can verify. Do you wish to switch? Some double checking, and yes, you can switch. It does the switching. The signal is back. Okay, we successfully switched. Oh, that's great. Oh, do you maybe want to create a trouble ticket for this incident? Oh, yeah, maybe that's a great idea to immediately create a ticket so that somebody can work on that and add some comments, and it's automatically creating a new ticket for you. Okay, so that's an example of an automation script that is triggered by an event in your system, and it's going out to all the people in the class, finding somebody. The first person that takes ownership will take the interactive automation script. If nobody would have replied within 100 seconds or whatever they defined, it would go and switch anyhow, for instance. You can choose what to do then. Note, if you click on ignore, it would actually be in the audit trailing that you ignored it. So that's everything is being tracked with audit trailing. So that's the interactive finding we can do and the interactive automation scripts. What else is available? Just some plain simple comments. So we can add comments in there. There was an option on top to add the comments as logging. You can actually also add that as a special comments line in there. Those are a little bit more advanced things. We don't need to worry about that. At any point in time, somewhere, if you get into some if condition and you say, oh, this is happening, you can always exit the script. So at any stage in your script, you can say like, ooh, let's stop here, and you can exit with a success or a failure and an optional reason. You can also set an element state, activate, start, restart, stop, pause, mask or unmask an element. So that's one of the state actions you can do on a dummy. And you can also assign an alarm or trend template. So during your automation script, you can change alarm templates and trend templates as well. So during the night, you can execute an automation script that will change your alarm templates on your system for some maintenance or anything. Well, maintenance typically you will mask, but maybe for a device that only is operational during certain periods. Assigning a dummy to a dummy or an element to a dummy, that is to change your dummies in there with a certain variable you have, if you have the name in there. You can just clear the contents of your memory file if you want to start all over again. A simple logging can be added to the log file of the automation, just from audit trailing, you could say, with potentially some variables you want to log in there as well. There's a go-to and a label as well. So that's wherever you're reaching a certain point in your codes, you can do a go-to and give it a name of a label, and somewhere else you put a name of a label and jump back. It's not the most ideal way, but that's a way where you can jump back in the code, so that you can do a little bit of a for or a while loop, you could say, but you have to be very careful with these kind of go-to labels. That's not always the most ideal thing. Therefore, you can do the real for while thing in C#. There is a building block you can add in C#. So you can actually create, I said you have two types of automation scripts. The dummy proof version with just some get set actions as we were discussing already. And you have the C# version. Well, actually you can make a mixture. You can do a couple of dummy steps there and then do a little bit of C#, then maybe some interactive automation, then a little bit of C# again. So you can actually mix and match. I will skip this for now. I will first do a simple example, and then after lunch we'll do a C# version. Once we created our automation script, we can of course run it. You can run it manually. That's what we will do by clicking on the execute button. We created something. We can click on execute. You can also do it via the scheduler, the automation, the Visio files. So we know that by now. If we execute it, it was always, I skipped it up to now, always a little bit the same thing. We actually have our scripts here, change output levels of IRDs. In this case, it needs only an IRD. That's the dummy. That's the dummy we see here. So in this case, it requires a dummy, an IRD. It could have like a source and a destination it needs, two dummies. You need to specify from which device to which device you want to copy the settings. In this case, it's only one IRD. It doesn't require any parameters or memory files or something like that. So we'll actually make one with a parameter. So in this case, you can just execute it on a Philips device, you choose it and you execute. So without going to the checkboxes, you can immediately start executing it, of course. What are those checkboxes? The first one, wait for the script to be finished before continuing. That's actually if it's asynchronous or synchronous. Do you want this pop-up to stay there, executing and waiting until it is finished and saying you success or fail? or do you just want to execute it and forget about it? And the window will close and you can continue your work. Maybe it's going to take 5 minutes, the automation script. I'll see in the information events, I can follow the progress there. And I can also, it will generate a notice when it would fail. Normally, a set command will also always be verified if it was successful. So whenever we do a set to 6 dBm, we will verify is it correct, and then it will continue. So that's an extra check that is always being done in the automation engine unless you disable this checkbox. Locking elements, we saw that elements can be locked so that nobody else can do something with it. The automation engine can also lock your element. So it locks it, it does its thing. You can, during that time, not do any sets on it while the automation is doing its thing, and then it will unlock again afterwards. The force lock is that you just kick somebody else out if somebody else would have been locking the element, and wait until when locked or busy. So if it's locked, it will wait until it's unlocked. Otherwise, it would fail. And mark as in use is more for the scheduler templates. That's not so important. Okay, let's do an exercise. So we'll first do this exercise, and then we'll have lunch. And after lunch, I'll go through the C# part. So that's the plan. Okay, so our exercise is creating a brand new automation script with the name training _ your first name. Add a dummy for a Philips device. So we're going to be executing it on our Philips device. And in short, what is the problem? We want to change the audio output level, but changing the audio output level, we know there's like a best practice procedure. So we will ask a new input. We will add an input parameter with the name level. So when you execute it, the person that executed will need to specify on which Philips device, and they will need to specify a new audio output level 6, 9, 12, and then the automation engine will do that for you. What is the procedure? Well, if the LMB1 supply is on, we first need to turn it off. So you are actually not allowed, let's assume, you are not allowed to change the audio output level just like that. It's better to turn off the LMB1 supply. So if it's on, we turn off the LMB1 supply. We sleep for 3 seconds. We need to wait a little bit until the device has cooled down, you could say. Then we set the audio output level, and then we set the LMB1 supply back to on again. And generate an information event that we were successful. We're going to execute that on our Philips device, and then we can apply that on our correlation. It's not really necessary. Okay, let's take a look at our automation engine again. I already created our 000 folder, and I already created my BERT VA script in there. If you didn't create a script yet, right click and add a script in there, specify the name. You can already save the script. Let's forget about dummies. Let's forget about parameters. Let's forget about memory files. Let's immediately dive into the action. What is the first action we need to do is we need to say if the LMB1 supply is on. We need to do an if. Open up the ads and go for if. It will immediately add a whole building block if. Let's go back to my slide. What's the first thing? If the LMB1 supply is on. Okay. If the LMB1 supply, that's a parameter. So if the parameter, and not sure if that's so visible. And what's the first drop down? Yeah, we need an element. Yeah, we didn't create, I specifically didn't create a dummy. So you can immediately create a dummy for here. If you didn't create your Philips dummy yet, you can just click on there and it will automatically add a new line in there, the same thing as clicking on add. And what kind of dummy do we need to have? We need to have an IRD. So that's just an arbitrary name, but give it a nice name, because that's what the user will see when he executes your automation scripts. So we need an IRD. It's going to be a Philips IRD, DVS3810. The version, it should by default select production, of course. It didn't do that, so I manually select the production. I always use production version. What is configuration elements? That's a little bit more special. That's just, you can pick one of the existing devices we have to configure your automation script, because sometimes with a matrix, you have labels on the inputs and the outputs. And if we would just use matrix from a certain vendor, you would just have input 1, 2, 3, 4, 5 up to 128, for instance. If you choose a specific configuration element, you would see the actual labels from that configuration element. Not applicable for us now. Okay, so let's go back. Now I created my IRD dummy, the IRD placeholder. And now if I click on there, I have my IRD in there. So I select if the IRD, and the second drop down is for our LMB1 supply. If the LMB1 supply is equal to the value, that's all fine. The value, and I click on the not initialized, and I say if it's on. If it's on, I first need to shut down the device before I will be able to change it. So if IRD LMB1 supply equal to value on. All the other stuff is fine. Okay, so that was my first if statement that I added. Now the second, within that if, within the then section, I need to set the LMB1 supply to off. So I add an action in the then part, a set. So let's do our first set. Set the parameter of the IRD. It's already taking that dummy because it's only one dummy, so it's easy. And I can just go to the LMB1 supply, set it to the value, and there I can set off. Yeah, and this one you need to go to on and back to off before the OK is enabled for one or another reason. So if you're not able to select, click on the OK, you first need to go to on and then to off, and then you can click on the OK button. So if the LMB1 supply is on, set it to off. An additional thing is I need the device to adapt a little bit to the new situation. So I add a sleep in there, and I will add, it says in the slides of 3 seconds, but that's a little bit short to notice the difference. And we have a delay actually on our Philips devices currently. So I'll add 10,000 milliseconds. That is 10 seconds. That still is. Okay, so the next step is changing my audio output level to the value that the user specified. Okay, now be careful. I no longer have to do this within the if statement. The if statement is only there if the LMB1 supply is on, I turn it off. If it's already off, I immediately can set the audio output level. So that's the reason why we had the if statements. That's only to make sure it's off, but I don't need to turn it off if it's already off. So the add of the audio output level, you do that with the very last add that is on your window, not in the else, not in the then, below that if else statement. So there you do the set on your of a parameter on the IRD, and that's my audio output level. my audio output. To the value 0 dBm? No. We're going to ask the user. So we're not going to go to a hard-coded value. Instead of value, we will click on value and we will go for variable. Which variable? Let's click on the empty there and open up the drop down. I don't have anything yet except create script input. Yes, I need input from the user. So I'll create on the script input and it adds automatically at the top a parameter. So I will not ask the user param1, but I'll ask them more nicely new audio output level. And he will be able to specify there 6 or 9 or 12 or whatever he prefers. Okay, so that was our set of the audio output level. And then the next step is turn the device back on and generate an information event. So we're going to do one more set again, just at the very end. One more set on the parameter IRD, not audio output level, but turn the LMB1 supply on again to the value on. Okay. And my last and final is generate an information event. Information event. Executed. VA. Okay, let's save my script and let's take a look on let's execute that on my Philips devices. So let me just show you what I did. I click on the execute button. I have my window open. That's a pop-up, but I went to my second workspace where I still have my equipment open so that I can take a look. So I still have this window to execute it. I'll execute it on my main device. My audio output level is currently 18. And let me check, my LMB1 supply is on for the moment. Okay. So let's execute it on my, which device there? The BERT VA main. The new audio output level, let's put it to 6. Wait for the script to be finished. Yeah, that will do it and show if it's successful. Execute. So it's executing it. You will see the LMB1 supply. We have a little bit of a delay on our equipment. So it goes to off. It will wait 10 seconds now. So I can see in the LMB1 supply, it has been changed by the automation script training BERT VA. So you can verify it over there as well. Let's go to the audio output level. So this one takes a little bit of time, the 10-second delay and the delay on our devices. And then this one will also change. Oh. It was not changing fast enough, or what? Apparently our device is not responding fast enough, I guess. So what we will do is I will execute it again. Let's go back. I'll execute it again on my BERT device. BERT VA main to 6. But what I will do is after executing a set command, check if the read parameter has changed. I'll disable that option because that's the one that is bothering us and causing an extra delay as well. So executing again, so it's going to be turning off and then it's going to change our audio output level to 6. Ah, here it is. Indeed, I made a mistake. Thank you. The set I created an input by clicking on create input, and then I went on top to actually configure it, but I didn't go back and make sure that this new one was selected. So if you have the same problem as me, set the audio output level to the variable. We still need to configure that new audio output level there. Save. Now it's going to work. Thank you very much. Let's execute and see the alarms. It doesn't really matter. Bert's IRD main 6. I can just leave it as it is now. So let's try again. And now I should expect a 6 to appear on my audio output level. Yes, there it is. And I can see that the audio output level in the details has been changed by my automation script. So you can play with or without the LMB1 supply on. So note we added that if statement. If your LMB1 supply is on, you will have the lengthy sleep of 10 seconds. If you turn it off yourself before you execute, you will immediately go to the sets in here. You won't do the if statement. You don't have the delay of 10 seconds, but your set of your audio output level to the new variable might still have a little bit of a delay of let's say 5 seconds or something we experience on our Philips device. Okay, let's continue with our automation. Just before lunch, we had our first exercise on creating an automation script. Just a quick recap on that. So we created an automation script that did some reconfiguration on my Philips device. No, actually on any Philips device. We can choose on which device we execute it because we use a dummy, a placeholder. So we had that one dummy IRD Philips device. We executed some actions on it, and we also asked the user for some inputs on which audio output level it should be set, 6, 9, 12. So you can specify that with an input parameter. Now let's go back to my slides because I skipped. I already have some windows open here. Because I skipped one thing there. And let's go back. That's the automation. The C#, I mean. Automation. It's all automation here. So I had all the different actions. And there was one action that I can add. C# codes. And that one I skipped. Let's take a closer look at that. So at any point in time in your automation engine, you can add a C# code block. If you will do that, you will have a block there, as indicated here in the slide, with some C# codes in there, some advanced section. Let's take a look on what exactly that means. If you are familiar with C#, you will see that you can do very powerful things with that. Because you can talk to the engine. You can already see some things there. Engine.generate information. So you can just type and start talking to the engine, call all kinds of methods on that thing, on that engine object. Of course, to make it a little bit helpful, we made a nice editor. Note you can open up the editor a little bit bigger. I'll do that in the example. We have keyword highlighting, so it does nice keyword highlighting. We have information on the methods, meaning if you are typing something like engine dot or dummy dot, it will automatically open up all the different methods you have on there. So you don't really have to go to a help. It has immediately in here all the information on all the methods you have. If you choose a method like engine.getDummy, it will give you a nice tooltip with what that getDummy does. It requires a string, and actually you have two methods, two ways. Instead of having a string, and maybe it's also an integer. and it gives back a script dummy. It gives you some more explanation and also each time an example that you can just type over. So you can just say script dummy dummy test equals engine.getDummy, something like, I don't know, it's cut off here. So that allows you to, even without having a lot of knowledge, very easily just start with an automation script. Start typing engine dot, you see the methods, you choose a method, you have the tooltip on what exactly or how exactly you should type it in your C#. And even more, if you right-click anywhere in the code editor, you have the copy-paste things in your right-click menu. You have at the bottom sample snippets. And here you get a jump start, and you can choose one of those sample snippets, and you can just immediately just have a piece of code in there doing something like, let's say, an edit spectrum, sending an email report, getting a parameter, setting a parameter. I can show you in some example that we will do in just a second. Note, if you open up the advanced that we have here at the bottom, so if you open it up, normally it's collapsed, you can reference some other namespaces in the .NET framework, and you can also reference DLLs. So if you have a DLL somewhere doing some magic, you can actually put it on the DataMiner system, and you can also reference your DLL to jump from your code here into your DLL, do some execution there, and can continue here. So that is also possible. Now, if we add C# code in there, there is first of all a naming convention you might want to follow to make sure that the IntelliSense that we have in our code editor works. The IntelliSense works on engine, on the keyword engine, because that's the DataMiner engine you're talking to. You don't have to create that variable. But we also will then do certain things like getting a dummy, so we create a dummy, and memory files and parameters. Always make sure that the variable name that you have will start with dummy or mem or param, or each time a little bit like you have it in the tooltip indicated. So the tooltip does it nicely as you should do. If you take your dummy IRD, for instance, that we have, and you request your dummy IRD, you have it from the engine. And if you would call it just IRD without dummy in front of your variable name, the IntelliSense with all the methods would not work. The code will work, but the help, the IntelliSense will not work if your dummy does not start with dummy. Now, on the right-hand side, that's the class here. You have the two possible ways of creating an automation script in C#. The upper one is the easy one, and that's just the scripting way, you could say. It goes from top to bottom. It's just you start typing in there engine dot do something, and I set a parameter, and I just start. That's the easy and most basic way. But if you want to take it a step further, and you want to go object-oriented with classes, etc., then you can actually go for the second example. And the second example is the most easy form, you could say. If you want to use classes with methods like we have here, this is just immediately some code. It's just top to bottom. Here we can do classes. If you do it, you need to start like this. You need to have using Skyline DataMiner automation. And then you need to have at least one class, a public class with the name scripts. And within that class, you need to have at least one method, and the method must be public void run and accept the engine object. And that's going to be your starting point of your automation script. So if DataMiner executes this code, normally with the above example, it basically wraps around this thing. If you want to do it yourself, you can basically do this, and it will start your code by instantiating a script class and running the run method there, and give you the engine object, and that's your entry point. Engine.generate information. Here you start, and from here, of course, You can instantiate other classes and variables and go to other methods and do all kinds of object-oriented programming in there to jump from one to the other and do the whole shebang in there. So either you go for the easy top to bottom, or you go for the class example we have here and go full object-oriented. Okay, let's take a look at that and create some example on our DataMiner system. So let's go back to our automation scripts. I'll leave the automation script as it is, or there's something modified. I'm not really sure. Discard the changes. I'll create a second new automation script. So I right click on the training folder and I add a script in there. I'll give it the name training underscore Bert VA. That already exists, underscore C#. Okay. I will immediately jump into the actions and add a one building block only, being the C# code. If you want to make this a little bit bigger, at the bottom of the editor, you actually have a splitter and you can actually open this up to make this a little bit bigger. Yeah. Was that mine or was that? Mine is gone. There's an update and let me add it. Yeah. Let me add a new one. Underscore C#. Oh, and my username, of course. Ah, and it already exists. So it is still on there. Oh, let's create two. Let's save it first. Maybe I need to save it first. Now I have mine, C#2. Add one action in there, C#. And I should be able to open it. Yes. It's just because somebody did an update or something, probably where it got confused. Save. Yeah, everything is working fine. So I have my script and I added only in there one action, being the C# code, and I can right click in there. Allez. And I can right click in there and I can actually go for sample snippets. So if you're not familiar and you want to get a jump start, you can go to sample snippets and, for instance, let's go for set parameter. Let's take a look at set parameter, what that means. Well, what it will do is it will go to the engine and it will get the dummy IRD. I would still need to add the dummy IRD. And it will make a new value 1, 2, 3. And it will say to the dummy, set the parameter like audio output level, for instance, to the new value. If you want to type that yourself, you can just start engine dot, and you immediately see all the different methods in there. So that was the get dummy. If you take that one and you open up the parentheses, you will see an example, script dummy tests, get the dummy matrix. So very simple, you can do those things. If you have the dummy dot, what can I do on a dummy? It has things like an element ID and an element name and things like that. I can get a parameter, I can get all kinds of table things, some matrix stuff is in there if it's a matrix, the polling IP, I can change the alarm template, set a parameter of course. So start, stop a device, I can do all those actions on there. So that's how you can very easy start and create your automation scripts. I don't want to work with a dummy. I already gave you an example where we are working with a dummy and we are making an IRD dummy where we change something. I'm not going to make the same example. I'm just going to delete everything. what I will do is I want to have that special feature there. Remember that I explained that we once had a customer that requested a feature where you were having your system all green when the customer came in. So he has a world map with lots of alarms. So if a customer comes in, he wants it green. Well, let's do that. How can we do that? Well, actually, if we type engine dot, you will see that in there we have a very interesting set of find elements. We can say we're not going to work with dummies, but we will find our element ourselves. And you can do something like find elements by name, that will probably be, and by protocol. And what I want is I want to find elements in view. So I'll go for the find elements in view. And I want to take all the elements from my personal view and immediately then iterate over all of them and mask them. I could do that for the whole of Europe or the whole system, but I'm going to limit it to my view. So engine.find elements in view. I open up the parentheses. I can give a name of the view, so that's going to be something like Bert VA. Bert VA. Okay. And in case you missed it, you can open up the parentheses. Whoa. Let's open it again. In the tooltip, you can see I will get an array of elements. So you just need to type that over. Element, array, and the name of the variable is elements. Element, array, elements, equals engine dot the whole thing. Okay. And now I can type for each. But actually, we're not in a C# course. I will stop here. And I will make it easier for you. Instead of doing that, you can just right-click, go to sample snippets, and you can go to mask all elements in a view. Mask all elements in a view actually does the same thing. So we already have it there. String my view, that's going to be Bert VA. So it did engine find elements in view. The view name, well, you can immediately specify it in there as well. So it gives you back an array. And I do a for each of each element in that elements array. And I can mask it with a certain. What can I do? Let me see. Mask. I have two possible ways of masking. Masking with a reason. So the name there. And masking with a reason and the number of seconds. So let me just add also the number of seconds behind it. So let's say for instance, 30 seconds. So the customer will only pass by the window here and see our screen for 30 seconds. And then it can go back, all the alarms. So masking, and I will maybe add the comment there. Customer passing by. So I take all the elements from a view. I iterate over them. And I mask everything for 30 seconds. Let's save that script. And there are no things that I need to specify as a user to execute it on. So I'll just execute it. Only the checkboxes, the options are there. I'm perfectly fine with that. And you will see that it succeeded. So my view, it actually went gray because there's nothing yet, nothing in there anymore that is still monitored. So maybe we need to make sure that we have something skipped that is not gray but green. So that's how you can, with one click of a button and with a small piece of code, iterate over a whole bunch of devices, do actions on there, even without specifying your dummies, you can find the element yourself as well. And after 30 seconds, it's unmasked. Any questions on the C# version? If you're familiar with C#, it is quite powerful to go there. Typically, if Skyline makes an automation script for a turnkey project, we will rely on the C# version because it goes a lot faster to develop in that.
Could you have done exactly this with the dummy thing?
No. So you can do more with the C# version. In the regular version, you can work with the dummies, but you cannot find elements in a view.
I don't know if you can show it, but putting a script button on the visual page, are you gonna show, or was that something you went through yesterday with the Visio and pick?
I didn't really intend to show that, but I can. Well, with the Visio, we linked this shape to a view, to an element, to these kind of things. So if I want to edit and I want to link this to the mask button, how can I do that? Well, we select that sheet.4. Yeah, that's the thing here. Or you can also right click on there immediately and edit from there. So I have my thing. It is currently linked to my backup device. Well, actually, it's linked to star. I no longer want to link it to an element, but I want to link it to an automation script. And then you need to click on the configure. And there you can choose your automation script, which is training BERT C#2. The options are here as well, but we don't need to worry about those. Well, well, you can do it asynchronous so that it happens in the background. You can. What is interesting here is don't show the confirmation box when the user clicks the shape, so it immediately executes. So you have these kind of things that might be interesting to do. Close, save that. It's opening Visio on my first screen to save it, and it's saved. So yeah, maybe I should change it then, of course, to have a nicer name on there. But you can see the tooltip is there, execute automation script and the name of my script. So I should maybe tweak that, but if I click on there, since I didn't ask for a confirmation, it's immediately executing that. So I just clicked on it and immediately it's masking everything. So whenever you see the customer coming around the corner, you click on the button and the alarms are gone.